In the frigid depths of international intrigue, a silent menace stirs. Russia's latest submarine, shrouded in secrecy, is said to possess the ability to decimate enemies in just a matter of seconds. Imagine the implications: stealthy, swift, and deadly. How did Russia engineer such a game-changing weapon? What capabilities does this submarine truly harbor that could turn the tide of global conflict? Join us as we explore Russia's secret submarine capable of wiping the US out in 30 seconds. Russia's latest torpedoes, known as Poseidon, are incredibly powerful. They are so formidable that Russia had to design a brand new class of submarines specifically to carry them. These torpedoes are the largest ever made, marking a historic leap in underwater weaponry. Consequently, the submarines equipped with Poseidon torpedoes are poised to be among the most formidable in the world. This advanced submarine torpedo combination could potentially shift Russia's strategy in Ukraine. Despite relentless bombardment from both air and ground forces, Ukraine remains resilient and far from defeated. As a result, Russia seems to be turning towards its naval capabilities as a strategic option, as reported in the news. Back on March 1st, 2018, Russian President Vladimir Putin unveiled 6 groundbreaking strategic weapons, including the Poseidon nuclear-armed torpedo. This weapon has gained significant attention in Russia, appearing prominently in TV broadcasts featuring Putin and becoming a focal point in Russian media discussions. There have even been wild speculations, with one commentator suggesting that the torpedo could generate a massive radioactive tsunami capable of wiping out the United Kingdom and severely damaging NATO's military capabilities. Despite these advancements, the Poseidon torpedo is only one part of a larger puzzle. Despite efforts to expand its arsenal, the sheer sophistication and unconventional nature of these weapons mean that out of Russia's 58 submarines, only 2 are currently capable of deploying them. Both of these submarines began construction over 3 decades ago, hinting they may be outdated for today's modern battlefield. This view seems to be shared by the Russian military, which is now focusing on building 4 state-of-the-art nuclear-powered submarines. 2 of these submarines have already had their hulls laid down, showing ongoing progress. Simultaneously, the Poseidon torpedo itself continues to evolve. According to a Russian media report, the first batch of Poseidon torpedoes has been delivered to the military. These torpedoes are set to become a symbol of modern Russian underwater weaponry. The Poseidon stands out due to its nuclear-powered, nuclear-armed design and its significant size, 3 times wider than a typical heavyweight torpedo. This makes it more akin to a kamikaze submarine, packed with immense nuclear energy, rather than a conventional underwater explosive. Its advanced pumped jet nuclear propulsion system grants it nearly unlimited range, enabling strikes on coastal targets worldwide. Additionally, it can dive as deep as 3,300 feet, deeper than any American submarine, including the formidable Virginia class. In terms of speed, the Poseidon is exceptionally fast, with a top speed between 56 and 70 knots, more than twice as fast as American submarines and their defense torpedoes. However, its high speed makes it easily detectable from a distance, prompting it to often cruise slower until it's ready for a final dash or to evade enemies. Even at reduced speeds, coupled with its extreme depth capability, existing anti-torpedo defenses are inadequate to intercept the Poseidon. Developing new defenses against such a formidable weapon poses a significant challenge for the US, NATO, and other Western nations. Poseidon represents a revolutionary leap in weaponry, unlike anything seen before. Its design circumvents US ballistic missile defenses, typically used to intercept incoming missiles by taking an unconventional underwater route. Imagine it as an intercontinental ballistic missile that travels thousands of miles across oceans. But instead of flying through the air, it swims silently beneath the waves. After days of stealthily navigating, the Poseidon reaches its target. Here it unleashes its destructive power. A 2-megaton nuclear warhead detonated either on land, creating a devastating mushroom cloud and fireball, or underwater, generating a radioactive tsunami that engulfs and contaminates the target area. However, there is skepticism about the effectiveness of the tsunami approach. Some analysts argue that even a large nuclear explosion wouldn't produce a natural-sized tsunami. and the energy would disperse in all directions rather than concentrating its destructive force. Moreover, morally, such an attack is considered excessive and a potential crime against humanity, given the catastrophic health effects of radiation-contaminated water. The development of such a weapon by Russia caught many by surprise. For years, Western officials doubted Russia's intent or capability to create such unconventional and powerful weapons. It wasn't until the 2010s that the reality of Poseidon's existence became undeniable. Russia's rationale for developing Poseidon is rooted in strategic deterrence. It's not intended for conventional conflict scenarios, but as a second strike capability. This means if Russia were ever subjected to a surprise nuclear attack, Poseidon ensures that any aggressor would face devastating retaliation. While traditional nuclear missiles already serve as deterrents through mutually assured destruction, Poseidon represents a sort of MAD 2.0 inches strategy in response to advancements in American missile defense systems, particularly after the U.S. withdrew from the Anti-Ballistic Missile Treaty in 2002. This treaty was crucial in calming the need to develop more unstoppable nuclear missiles because it ensured that the existing nuclear-capable weapons were potent enough to deter any country that dared provoke Moscow. However, with the U.S. withdrawing from the treaty, the desire to create invincible nuclear-capable missiles has resurfaced. The outcome? Poseidon. The U.S. has been exploring various strategies to defend against Russia's new torpedo. These efforts include enhancing stealth, speed, and depth capabilities and countermeasures. Potential solutions range from faster anti-torpedo torpedoes to expanding stationary seabed sonar surveillance. There's also talk of developing ballistic or hypersonic missiles that can deploy homing torpedoes swiftly enough to intercept a Poseidon once it's detected. Yet this defensive pursuit could provoke concern in itself. Russia, aware that Poseidon's invulnerability might be compromised shortly, could be inclined to utilize it before such defenses are fully operational. If this were the case, Ukraine could undoubtedly be a primary target. With Russia's ground invasion of Ukraine stalling, attention might shift to the seas as an alternative strategy. Russian submarines in the Black Sea could target ships transporting Ukrainian exports, such as wheat and other vital resources. This scenario presents a significant challenge for Ukraine, already grappling with a massive ground war against the Russian military. The question then arises, would Russia deploy Poseidon against Ukraine? Some experts speculate that the escalating conflict might push Russia towards such a drastic move. Ukraine would find itself severely limited in its options to respond effectively. The country lacks sufficient anti-submarine warfare equipment, making it difficult to mount a robust defense. Even Western allies would struggle to assist, as the necessary platforms Ukraine would require are both costly and in short supply. Even if these platforms were donated, Ukraine would face challenges in quickly staffing, operating, and safeguarding such high-value assets. Turning to submarine warfare could potentially expose Russian vulnerabilities rather than showcase Ukrainian strength. Russia's navy significantly outmatches Ukraine's fleet of older Soviet-era warships. Yet Ukraine has shown resourcefulness by utilizing locally produced Neptune anti-ship missiles to successfully target and neutralize Russian surface ships like the flagship Moskva in the Black Sea. This has prevented Russian naval forces from supporting ground operations with naval gunfire or conducting amphibious landings behind Ukrainian lines. However, dealing with Russian submarines and their torpedoes presents a different challenge. Submarines are stealthy and may evade detection by Ukrainian forces until it's too late to respond effectively. Despite these threats, like other Russian military actions, such tactics would unlikely diminish the resolve of the Ukrainian people. Nevertheless, they could have a significant impact on Ukraine's economy, particularly since the world depends heavily on Ukrainian exports of wheat, corn, and sunflower products. Russia has faced criticism for worsening global hunger and driving up food prices by disrupting Ukrainian grain exports. In response, under pressure and through a United Nations-backed agreement, Russia has allowed some Ukrainian grain to be shipped through safe corridors in the Black Sea. This measure aims to alleviate humanitarian concerns while balancing regional security dynamics. In summary, submarine attacks wouldn't break Ukraine's resolve, which remains steadfast and unyielding. While these attacks could inflict damage on the Ukrainian military, Russia has committed not to escalate in that manner. Furthermore, Russia views Poseidon as a deterrent against other nuclear powers, rather than a weapon to be used in the current conflict with Ukraine. Therefore, it's unlikely that Poseidon will be deployed in this war, and ideally, it shouldn't be used in any conflict anywhere. Russia's new submarines are crucial strategic assets as tensions persist with Ukraine and Western nations. The Poseidon torpedoes they carry are intended to bolster Russia's deterrent capability, although some view them as an excessive and unnecessary threat. Now, with the capabilities of the Poseidon torpedoes in mind, let's delve into some of the most exceptional attack submarines ever built. The Seawolf-class submarine is renowned for its staggering cost of approximately $3 to $3.5 billion per unit, making it the most expensive submarine in history. Originally designed during the Cold War era, it aimed to surpass the capabilities of the older Los Angeles-class nuclear-powered attack submarines. The Seawolf's primary objective was to maintain the USA's superior acoustic advantage over Soviet submarines. However, with the Cold War's end and a shift in naval strategy towards littoral or coastal operations, the Seawolf's exorbitant cost became prohibitive. Consequently, the program was scaled back in favor of developing the smaller and more cost-effective Virginia-class attack submarines. The Seawolf boasts impressive specifications. It has a submerged displacement of around 9,140 tons and 8,060 tons when surfaced. One of its standout features is its exceptional quietness, even at high speeds. While most submarines must slow to less than 5 knots to evade detection, the Seawolf can cruise at up to 20 knots without being easily detected. It can dive to depths of up to 1,610 feet and was equipped with retractable bow planes to operate under ice-covered waters. Armed with formidable weaponry, the Seawolf includes 8mm torpedo tubes capable of launching potent torpedoes and missiles. Originally designed with larger tubes to accommodate future weapons, this feature was never utilized due to the program's curtailment. The submarine's armament includes up to 50 weapons, enabling it to sustain operations in forward combat areas for extended periods without resupply. These armaments encompass both land attack and anti-ship versions of the Tomahawk missile, with a range of 1,350 nautical miles, as well as Harpoon anti-ship missiles with a range of 70 nautical miles. Additionally, it carries Mk-48 torpedoes designed to engage high-performance surface ships and fast, deep-diving submarines. The Seawolf submarine design was specifically crafted to counter the threat posed by advanced Soviet submarines like the Typhoon and Akula classes, particularly in deep ocean conditions. These submarines are constructed with HY-100 steel, which is stronger than the HY-80 steel used in earlier classes, ensuring they can withstand greater water pressures at deeper depths. Compared to their predecessors, the Los Angeles-class submarines and Seawolf-class submarines are larger and faster. These submarines are also equipped for shallow water operations thanks to advanced technologies such as the RCI-modified AN/BSY-2 combat system. This system includes a larger spherical sonar array, a wide aperture array, and a new towed array sonar, enhancing their detection capabilities. Powering each Seawolf-class submarine is a single S-6W nuclear reactor, generating 45,000 horsepower to propel the submarine through a low-noise pump jet propulsion system. In contrast to the Seawolf's costly and limited production, the Virginia-class submarines have since become the mainstay of the U.S. Navy's attack submarine fleet, offering a blend of advanced capabilities at a more manageable cost. The Virginia-class submarines, initially developed under the codename Centurion and later renamed New SSN or NSSN, began with the Centurion study in February 1991. This marked a significant milestone as it became the first U.S. Navy warship to utilize advanced 3D visualization technology like CADIA. This technology integrates computer-aided engineering, computer-aided design, computer-aided manufacturing, and product lifecycle management. By 2007, approximately 35 million labor hours had been dedicated to designing the Virginia-class submarines. Construction of each submarine has required about 9 million labor hours and involvement from over 4,000 suppliers. Over its projected 33-year service life, each submarine is expected to undertake 14 to 15 deployments. The Virginia-class was conceived partly as a more cost-effective alternative to the Seawolf-class submarines, which cost $2.8 billion each. To mitigate costs, the Virginia-class submarines incorporate many commercial off-the-shelf components, particularly in their computer systems and data networks. Advances in shipbuilding technology have further reduced production costs below the initially projected $1.8 billion in fiscal year 2009 dollars. The Virginia-class submarines are constructed under a unique industrial arrangement aimed at sustaining both GD Electric Boat and Newport News Shipbuilding, the only two U.S. shipyards capable of building nuclear-powered submarines. In this arrangement, Newport News Shipbuilding handles the construction of the stern, habitability sections, machinery spaces, torpedo room, sail, and bow, while Electric Boat focuses on the engine room and control room. They alternate work on the reactor plant and collaborate on final assembly, testing, outfitting, and delivery. This dual-yard strategy is considered more costly, but offers several potential benefits. One significant advantage is that it ensures the United States can continue submarine production at one yard, even if the other yard faces a prolonged shutdown due to catastrophic events like an enemy attack. The Virginia-class attack submarine stands as an advanced, stealthy, and versatile nuclear-powered vessel designed for a wide range of missions, including deep ocean anti-submarine warfare and littoral operations. Currently, the U.S. Navy operates 19 submarines of this class, with an additional 9 units under construction. The submarine's hull spans 377 feet in length, with a beam of 34 feet and a displacement of 7,300 tons when submerged. One of the Virginia-class's standout features is its low noise level, nearly indistinguishable from natural ocean background noise. This acoustic stealth capability allows it to operate covertly even at speeds of up to 25 knots underwater. However, compared to the Seawolf class, the Virginia-class has a more limited diving depth of 800 feet, driven by cost reduction considerations during its design phase. Armament-wise, the Virginia-class submarines carry a similar array of weapons as the Seawolf class. These weapons can be fired from traditional 4mm torpedo tubes, as well as from 12 vertical launching system tubes. This dual launch capability gives the Virginia-class submarines a formidable edge, enabling them to engage hostile ships, submarines, and high-value land targets with precision and surprise, even within an adversary's air defense zone. Overall, the Virginia-class submarines represent a blend of advanced technology, operational flexibility, and strategic firepower, making them a cornerstone of the U.S. Navy's submarine fleet. The Astute-class submarine represents the Royal Navy's most recent fleet of nuclear-powered submarines. These submarines are equipped to carry up to 38 weapons, typically a combination of Spearfish heavy torpedoes and Tomahawk Block 4 cruise missiles. Each Tomahawk missile, which costs 870,000 pounds, boasts impressive precision, capable of hitting targets with accuracy to within a few meters and covering a range of 1,000 miles or 1,600 kilometers. In a significant upgrade scheduled for 2024, the Ministry of Defense plans to enhance these capabilities further by transitioning to the Block 5 standard Tomahawk missiles. These upgrades promise extended range and modernized communication and targeting capabilities. The Astute-class submarines are equipped with the Astute Combat Management System, a sophisticated iteration of the submarine command system used across other British submarine classes. This system integrates data from the submarine sensors and presents the information on command consoles. The submarines also feature Atlas Hydrographic DESO, 25 echo sounders for high-precision underwater mapping, along with 2 CM010 optronic masts that house thermal imaging, low-light TV, and color CCTV sensors, replacing traditional periscopes. Additionally, the class incorporates a successor EFF system for identification. For detecting enemy ships and submarines, the Astute class is equipped with the Advanced Sonar 2076 system, which combines passive and active search and attack capabilities across bow, intercept, flank, and towed arrays. BAE Systems asserts that the Sonar 2076 is the world's leading sonar system for submarine operations. All Astute-class submarines are slated to be outfitted with the cutting-edge Common Combat System, further enhancing their operational capabilities and integration within the Royal Navy's fleet. The Astute-class submarines are propelled by a Rolls-Royce PWR-2 pressurized water reactor, known as Core H, and use a pump jet propulsor for propulsion. This reactor, originally developed for the Vanguard-class ballistic missile submarines, boasts an impressive 25-year lifespan without needing refueling. This longevity allows the Astute-class submarines to be about 30% larger than previous British fleet submarines, which use smaller reactors. Like all Royal Navy submarines, the bridge fin of the Astute-class boats is specially strengthened to facilitate surfacing through ice caps. Additionally, these submarines can be equipped with a dry deck shelter, enabling special forces like the Special Boat Service to deploy while the submarine remains submerged. The Astute class features more than 39,000 acoustic tiles strategically placed to minimize the vessel's sonar signature. These acoustic qualities make the Astute class among the stealthiest submarines ever operated by the Royal Navy. The Astute class submarines are notable as the second Royal Navy submarine series, following the Vanguard class, to provide individual bunks for each crew member. This ended the previous practice of hot bunking, where sailors shared bunks on alternating watches. Despite this improvement, they offer less mess deck space compared to the older Valiant-class submarines constructed 45 years earlier. An audit by the Defense Board acknowledged mistakes regarding accommodation standards and crew quality of life issues. Due to their nuclear power, Astute-class submarines theoretically have unlimited endurance. However, practical limitations mean they typically stay at sea for up to 90 days depending on food supplies carried, which includes substantial quantities such as 18,000 sausages and 4,200 Weetabix. The Astute class is designed to achieve speeds between 29 to 30 knots, equivalent to 56 kilometers per hour. Overall, the Astute class submarines are considered some of the most formidable in the world, posing a significant threat to potential adversaries in the North Atlantic and Arctic regions. Their advanced capabilities in stealth technology ensure they maintain a superior position in underwater operations. Moving on to our next entry on the list are the new Russian nuclear-powered attack submarines, known as the Yasen class or Grainy class. These submarines represent a significant technological leap forward compared to the older Akula-class vessels. Despite being more advanced and capable, they also come with a higher price tag. The lead boat of the Yasen class, named Severodvinsk, began construction in 1993, but faced delays and funding issues, leading to a halt in the project in 1996. However, in 2003, additional funding was secured, allowing construction to resume. The cost of the first submarine of this class, Severodvinsk, was reported to be approximately $1.6 billion. It was officially commissioned into service in 2014. Currently, 2 more submarines of the Yasen class, named Kazan and Novosibirsk, are expected to be commissioned this year. Furthermore, construction is underway for 6 additional submarines of this class. The Yasen-class submarines are constructed using low magnetic steel, which reduces their magnetic signature. They are equipped with a spherical bow sonar system that enables them to operate effectively at depths of up to 1,475 feet. This advanced sonar technology enhances their capability for undersea operations and detection of potential threats. However, these Russian submarines are louder compared to the U.S. Virginia and Seawolf-class nuclear-powered attack submarines. Despite this, they are designed with specific missions in mind, such as targeting carrier battle groups and hunting down enemy ballistic missile submarines, attack submarines, and surface ships. The Yasen-class submarines are equipped with 24 vertical launch tubes capable of firing a variety of cruise missiles, including the P-800 Onyx and Caliber missiles. They also carry torpedoes and anti-ship missiles that can be launched from 8 650mm torpedo tubes. Reports indicate these submarines can carry up to 30 torpedoes and anti-ship missiles in total. In terms of stealth and operational capability, the Severodvinsk, one of the Yasen-class submarines, ventured into the Atlantic Ocean in 2018 and managed to evade detection for several weeks, showcasing its advanced capabilities. These Russian submarines pose a significant challenge to the U.S. Navy's Los Angeles-class submarines, which have long served as the backbone of the U.S. submarine force. Currently, there are 36 Los Angeles-class submarines in active service, with 26 having been retired from duty. The Los Angeles class holds the record for having more nuclear submarines than any other class worldwide. Its sophisticated electronic systems have made it exceptionally effective in anti-submarine warfare. In one notable instance, the advanced BQQ-5 system successfully detected and tracked 2 Soviet Victor-class submarines over an extended period. This class is armed with a formidable array of weapons, including the Tomahawk land attack missile, which can strike targets up to 920 nautical miles away, and the Mk-48 homing torpedo, with a range of 27 nautical miles. In total, the Los Angeles-class submarines can carry 40 torpedoes and 12 land attack cruise missiles. They have been involved in various military operations, including missions in Iraq, Kosovo, and Afghanistan. These submarines have also been active in Arctic operations, with the USS Scranton SSN 756 surfacing through the Arctic ice cap in mid-2001. Powered by a propulsion system that allows a maximum submerged speed of 33 knots and a service speed of 20 knots, the Los Angeles-class submarines are designed to operate at depths of up to 650 feet. In a dramatic display of military prowess, 4 Russian warships, including the formidable nuclear-powered submarine Kazan, have arrived off the shores of Cuba, anchoring just 200 miles from Florida. This fleet, comprising a frigate, a nuclear submarine, an oil tanker, and a rescue tug, made a grand entrance into Havana Bay on June 12th, ahead of planned military exercises in the Atlantic. Leading the procession was the advanced frigate Admiral Gorkov, which signaled its arrival with a ceremonial 21-gun salute, reciprocated by Cuban forces from a historic colonial fort guarding the port. Following closely behind was the Kazan submarine, accompanied by a rescue tug and an oil tanker. As the Russian frigate sailed into Havana harbor, sailors stood in impeccable military formation, drawing the attention of residents who paused to capture this historic moment with their cameras. The fleet's 5-day official visit to the Caribbean island is widely viewed as a bold demonstration of Russian naval power, strategically positioned just 90 miles from U.S. territory amidst heightened tensions over the Ukraine conflict. U.S. officials have expressed concern, speculating that the Russian ships may extend their presence in the region throughout the summer and potentially visit other allied nations like Venezuela. This deployment follows President Joe Biden's authorization for Ukraine to use U.S.-supplied weapons against Russian targets aimed at defending Kharkiv, Ukraine's second-largest city. In response, President Vladimir Putin issued a stern warning, hinting at possible asymmetrical global actions by Russia. Experts interpret this Russian naval maneuver as a direct response to Western support for Ukraine, showcasing Russia's advanced naval capabilities and its intent to exert influence in the Western Hemisphere. The presence of the Kazan submarine, renowned as a stealthy silent killer, highlights Russia's naval advancements. Commissioned in May 2021 as the second vessel of the Yasenem class, the Kazan, designed by the Malachit Marine Engineering Bureau and built by the Sevmaz shipyard, is a versatile and powerful vessel. With a length of 139 meters and a submerged displacement of 13,800 tons, the Kazan represents a significant leap in Russia's maritime capabilities. The Kazan submarine, powered by its nuclear propulsion system, excels in prolonged underwater missions, offering unmatched strategic endurance and operational flexibility. Capable of reaching speeds up to 31 knots when submerged, it asserts a formidable presence across vast oceans. Armed with 10 torpedo tubes and equipped to launch a variety of missiles, including the Caliber cruise missiles with a range exceeding 2,500 kilometers, the Kazan possesses a lethal arsenal that ensures precise strikes on both land and at sea. Its primary armament includes the Caliber and Onyx cruise missiles, renowned for their pinpoint accuracy over long distances. Enhanced by state-of-the-art sonar systems and advanced electronics, the Kazan excels in detecting and engaging enemy vessels with exceptional precision. Its acoustic stealth capabilities make it one of the quietest submarines operational today, enabling covert operations for intelligence gathering, surveillance, and strategic strikes. Designed for multi-mission versatility, the Kazan excels in anti-submarine warfare, anti-surface ship warfare, and land attack missions. Its impressive range and endurance allow it to operate far from Russian shores, projecting power globally. This combination of stealth, firepower, and versatility positions the Kazan as a formidable asset in Russia's naval strategy. The recent deployment of the Kazan and its accompanying fleet to Cuba has drawn significant attention from global military observers, signaling a notable shift in naval power dynamics, particularly in the Atlantic and Caribbean regions. The Kazan's capabilities pose strategic challenges to NATO and other naval forces, prompting advancements in anti-submarine warfare tactics and technology to counter this new threat. How much of a threat do you think Russian submarines pose to the United States Navy or the Royal Navy?